Hello everyone and welcome to Mathics. In this video, we're going to do Australian Mathematics Competition 2022. And as you see, it's going to be the senior level, okay, 11 to 12. And I know in about a month, a lot of you will take part in the competition in August. So just a quick points right before we start doing the questions. Uh, this is the most important tip I could give you. I think in a lot of tests, a lot of people, a lot of test takers, they forget to read about this. There is no penalty for an incorrect answer. That means if you don't know the questions, right, just go for it. Guess the answer, right? So you have at least 20% chance to get it right. If you could eliminate some of the options, you're sure then this will go up. So definitely guess, okay? That will increase your score so much. The next point is, okay, remember that the time is short and you want to manage your time. If you see a question that is too difficult and is wasting your time, I'll let it go and move on to the next question. I think nobody will be able to get all the questions and all the questions correct. Okay. So, and then I wish you luck for the test, upcoming test. In this video, we're going to do all the questions together from 1 to 30. Okay, let's start. Again, as you know, questions 1 to 10 are usually very easy. So I'll be doing them very quickly. Question 1, the temperature in the mountains was 4, but dropped overnight by 7. What was the temperature in the morning? So basically it's asking 4 minus 7, it will be -3. Okay, of course. Question 2, the rectangle shown has area 135. What is the value of h? So you just have to divide these numbers, like 135 divided by 15 right here. So it's going to be 9. Okay. So this one will be B. So question 3. What is this value? Okay. This would be 5 plus 16 plus 9. Okay, so far is 30 plus 16 plus 1. So 30, this is 30, this is 17, 40. It's not the options, I made a mistake. Okay, so here it was not 9, it was 27. So 47 we had, 18 more to it, 65. This would be the right answer. Okay, let's go question 4. We just have to minus these two. Okay. Actually, we're going to need this for one of the upcoming questions. So for this one, it will be, I will write it like this. I will factorize 1 over 2 from both of them. So it's going to be 1 over 10 minus 1 over 11. Okay, so 1 over 10 minus 1 over 11 is going to be 110 here. 11 minus 10 here. 1 over that, so it's going to be E. Okay, question 5. We have 3 vertices of a rectangle are these points. At which point do the diagonals of the rectangle cross? Okay, so we have x1 and 4 would be here. So x would be 1. This would be 4. Okay, another one starting with x1 is here. This is 8 then. So now y is 4. This is 7, so this would be 7. So now we have each length. So from here to here, this is 6. And 4 to 8, this is 4. Okay. So from this point, we had 1, and then we had 4. Okay. So from x1, we have to go half of this 6. So it would be plus 3. From this 4, we need to go up 2. So it would be plus 2. So the points will be 4 and 6, which would be A. Okay, good. So let's go the next question on the first page here. What fraction of this trapezium is shaded? Okay. So actually the shape inside of this biggest shape, this trapezium. Okay. How do we find it? 1 plus 1 plus 1 is 3. 2 plus 1 plus 2. So it's going to be 3, the top one, plus this 5 divided by 2. Okay. All of this multiplied by this h. So it would be 4h. Okay, so the big shape, all of this, the big trapezium is 4h. Now how about the small one? The small one is going to be this 1 plus 1 divided by 2 multiplied by h. So it would be this one, it would be only 1h. So what is the ratio? It would be h over 4h. So you see that the height is not important. So it will be only 1 over 4. Okay. Okay, question 7. The sum of the numbers on these 6 cards is 4 square root of 5. Lily removes one of them. What is the largest possible sum of the remaining 5 cards? Okay, we want it to be the largest. So that means we need to pick the least card, the smallest card, the card with the smallest value so that it becomes the maximum. See, all of these are positives, so positives are out. Between these two, which one is less, right? This one, this card, okay, has the least value. So we have all the sum, 4 square root of 5, and we're going to minus it by the value of this. It's also a negative value. Okay, so it would be negative would be positive. And we could also move it like this. Okay, 4 is also shared between them. We could factorize it, but we don't have to. 4 square root of 5, 4 square root of 7. Okay. Let's go and do question 8 now. In this diagram, what is the value of x? Okay. So the internal angles of any triangle is 180 degrees. This is also 90. That means this x plus this y is 90. So I'm going to write it. Okay. We also know that this angle x is equal to these two angles together, y and 40. So I'm going to write x equals y plus 40. Okay, in this equation, I'm going to replace x by y plus 40. So I'm going to get y plus 40 plus this y equals 90. So 2y is 50, y is 25. If y is 25, 25 plus 40 is 65. Here we go. Okay, question 9. The smaller of these dice has 3 zeros and 3 ones on its faces. Okay, we're talking about this one over here. Okay, 3 zeros, 3 ones. And the larger one has these 6 numbers on its faces. Both dice are rolled once and the numbers showing on top are added. What is the probability of obtaining a sum of 12? So we know this one has 6 ways of showing up. This one has 6 ways of showing up. Together they have 36 combinations. Okay. And now how many ways do we have to get 12 with these numbers? Remember, if it's 0, it doesn't matter what happens here. It's not going to end up being 12. But if we go 1 over here, this one has 11. But this 11, okay, has 1 chance of showing up, right? Only 1. But here we have 3. This one, and this one. So it will be 3 over 36. Okay, it would be 1 over 12. We could answer the question a little differently. So how is that? The chance of 11 showing is 1 from these 6 numbers. So it's going to be 1 over 6. The chance of 1 showing, we have 3 ones from 6 faces. So it will be 3 over 6, which is 1 over 2. We could multiply these two numbers. So 1 over 6 multiplied by 1 over 2 is 1 over 12. So, okay, we get the same result. So the value of this is closest to, okay, let's see. 24, it's we have to power of negative 1 over 2, okay? So to remove the negative from the exponent, we write this as 1 over 24, and then to power of 1 over 2. We know that power of 1 over 2 is the same as the square root of 1 over 24. We could also write it this way, 1 square root of 24. Because it said approximate, right? So we could make this one 25, and it would be 1 over 5. So this one will be approximately 1 over 5. So let's see the other one. This one the same way. To remove its negative, and this 17 will make it 16. So it will be 16, 1 over 16 to power of 1 over 4. Okay. So it would be the 4th root of 1 over 16. Okay, it would be, of course, 1 over 2. In case you wonder, 1 over 2 to power of 4 is, of course, 1 over 16. So here is going to be 1 over 2. But you see that the options are decimal values. This is equal to 0 0.2, 0 0.5, addition of them, 0 0.7. So let's do something. Question 11. this operation that we're going to define is defined by p blah blah q is equal to 2p minus q. Each of p and q is an integer from -6 to +6, okay, inclusive. How many pairs of values pq will have, okay, p blah 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 q is the same as q blah 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 p. It might be looking difficult, but it's not difficult at all. So I'm gonna block this so you have more space. Yeah, block myself too. Now let's leave it like this. Okay. So p over q, like whatever this is, we have the expansion of it. So this one, we write it like 2p minus q. So this one, q over p, is going to be the same as this, only p and q are replaced. So instead of 2p, I write 2q, minus, instead of minus q, I write minus p. Okay. So this negative q to the other side, this one to the other side. So it will be 3p equals to 3q. So p and q must be the same. Okay. So for all values that p and q are same and are equal, we got the answer. So how many pairs of values p and q will have this? Well, it would be -6 and -6. Okay, and then -5 and then -5. You will continue this 0 and 0, and then +1 to the last one will be +6 and +6 and +6. Well, they have to be equal, right? So 6 here, 0 and 0, 1, another 6 here, a total of 13. Okay. Question 12. In the diagram, the lengths of the sides of the triangle 8, 9, and 13 centimeters. The centers of the circles are at the vertices of the triangle, blah, 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 and the circles just touch. The radius in centimeters of the largest circle is. So now we just have to see visually, this one looks smaller. So from here to here, this side will be 8. Okay, this one will be 9. And this one will be 13. Okay, so the worst thing you could do is to write this one 8, write this one, for example, call this one A, and then call this one B, and then write the equations. A plus B equals 8. This is not good. Well, because this is a test, right? You just have to guess the right values most of the time. Okay, so let's just, to me, my eyes, let's call this one 3. Oops. This one is 3, so this one will be 5. Then this one will be 5. Okay. So then this one will have to be 8. This is 8, this one is 8. So this one will be 3 again, but 8 plus 3, you see that it's not going to be 9. So my guess was wrong. They're integers, I guess something else. So I'll make this one 2. So I'll make this one 2. And I make this one 6. And this one also 6. So this one will be 7. And this one will be 7. And you can see if I put here 2, it will be 9. That's it. So what is the question one? The largest circle radius would be this one, 7. Don't write equations for questions like this. Okay, let's go and do some cleaning. So question 13. The four integers 3, 4, 8, 11 have their mean range calculated. Okay. So in case you forget, you shouldn't forget, like the mean is the average. You add all the numbers together, divide by the number. Range is, for example, here, range is the biggest one minus the smallest one. 11 minus 3. Okay. And in case you forget, median is the number between. So right now, the median of this is the number between them. It doesn't exist. So the median would be 4 plus 8 divided by 2. Median is 6. And the mode is the number repeating. So for example, we have 3, 4, 8, 11. Each number is repeating once. So all of them are mode. Okay. But again, we don't need all of those. Just I wanted to give you a review. So now it says the range, which is 11 minus 3, is not going to change. Now a fifth number is then included. That is different from the other four. This doesn't change the range. Okay, but the mean is now an integer. Interesting. So when it says it doesn't change the range, the number could be, should be, is supposed to be between them. So not 3, not 4, maybe the number is 5, maybe 6, maybe 7, maybe 9, and maybe 10. So one of them is here. So by looking at the option, you see that 4 is definitely wrong. 8 is definitely wrong too. Okay. So now it says the mean will be an integer, right? So we just have to see this number. So let's find the mean. I said we just have to add all of them. 3 plus 4 plus 8 plus 11. Right now, this one should not be an integer, right? It would be 7 plus 8, 15, 26. As you see, 26 is not divisible by 4. So it will not be an integer. But if we add another number to it, plus x, and this one will be 5, it has to be divisible by 5. So we had these numbers. It was 26. If x is 4, then it would be divisible because it would be x 26 plus 4 is 30 divided by 5 is 6. So it's good, but we already have 4. So it's not going to be like this. A number that is different from these 4. So 4 is out. So the next number that could do the same thing is 9. Would be 35. If the number is 9, this one, okay, this would be 35 over 5. So 35 over 5 is 7. What is the new mean? It will be 7. This is 7. Two triangles, ABC, this one, BCD, this one, are both right angle as shown. Lines AB and CD are parallel, as you see this one and this one. And AC 1 and 2, we see it, of course. What is the length of CD? So in case you know a little trigonometry, you know that this one is 1, this one is 2, because this is half of the hypotenuse, this is 30 degrees. Okay, that means this is also these two are parallel, so this is also 30 degrees. So this is 90, this is 90, so this is 60, this is 60. So they are similar, okay? So, okay. But without trigonometry, if you don't know, there's nothing that passes my mind. Okay, now if you know again, so do we have this value of this line? Of course we do, right? This one is, the red one is squared plus 1 squared equals 2 squared, right? So this one question mark squared plus 1 squared equals 4. So this is the square root of 3. So again, this is 30 degrees. Okay. For this one will be half of the hypotenuse square root of this. Okay. And this one will be, because it would be square root of 3 over 2 multiplied by square root of 3. So 3 over 2. Okay. The reason I'm not explaining it well is because I'm not going to do it like this. This is the right answer. But so imagine you establish that they are the same. Okay, see, now without trigonometry, these are the same. So this is passing them. So this is the same as this. So if they are the same, that means because this is 90, this is 90, these two are the same. So they are similar. Okay. So if they are similar, so let's see here. We already said this is a square root of 3. So because these two are similar, the ratio of the lines are the same. So for the bigger one, this one, the hypotenuse over the second biggest line is 2 over square root of 3. Okay. Now for this triangle, again, the ratios will be the same. Why? They are similar. We proved they are similar. So again, for this one, we'll write the hypotenuse for this one is the square root of 3. Okay. So this one, the second largest one, is CD that we want. So I'm going to write that CD. Okay. So cross multiplication, we'll get the square root of 3 squared equals 2 CDs. This will be 3 over 2 equals CD. Okay, so it's up to you, right? Trigonometry was not necessary. Okay. So question 15. Now, if you just watch my other videos or similar channels that have videos, these types of questions like 15, they are very, very popular. And you see it in all channels that teach math. So 3 to the power of x, this one is the second one. Remember, I could write this one as, oh, my pen is not working. Okay, 3 to the power of x plus 1, right, is the same as, it's equal to 3 to the power of x multiplied by 3. Is that right? So if I ask you to multiply these two, what would you say? You say, okay, the power is 1, bases are the same. So you write them and then you add them, right? This is what you do. So now we just have to do it opposite way, opposite direction. So here, instead of this, I'll write 3 multiplied by 3 to the power of x. Okay, so the next one would also be the same. So it would be this one would be 3 to the power of x multiplied by 3 to the power of 2. So this would be 9. So plus 9, 3 to the power of x. And the first one was only 3 to the power of x. So we factorize the left-hand side. 9, 3, and 1. So how many of them do we have? We just count. 13, 3 to the power of x equals 13, the square root of 3. So both sides are canceled by 13. So 3 to the power of x equals the square root of 3. Instead of that, I could write it as 3 to the power of 1 over 2. Compare, x equals 1 over 2. Okay. So let's go. Do you remember, I think it was question 4 that I said we're going to need this later. So now is later. Okay, let's do question 16. Remember, we did this in question 4. We minus them. Subtract them. 4 numbers are equally spaced on the number line in the given order. What is the value of y? Okay. So let's see here. By the way, we know that this number is supposed to be, it's getting smaller each time, right? A smaller and then a smaller. If you think this would be the answer or you have doubt, that's not right. Okay, because here it says it has to be equally spaced. So each number from here to here is if it's minus by x, this one should be again the same value minus by x. This one is supposed to be minus by the same value. But the difference between 1 over 20 over 22 or these two, are they the same? If you have doubts, well, if you want to prove it to yourself, all you have to do, go with 2 easy numbers. So 1 over 2 minus 1 over 4, okay, is what? It's only going to be 1 over 4, okay. But here, 1 over 21 is 1 over 22. We said that in question 4. It was 1 over 220. Okay, so this is not very difficult. Each one, this one has been minused by this value. Again, minus one more time. Again, minus one more time. So the answer would be 1 over 20 minus 3, 220. So let's multiply this by 11, this one by 11. So what we're going to get, 11 over 22 minus 3. So which would be 8 over 22. And we simplify it by 4. We're going to get 2 over 55. Yes. Okay, so 2 over 55 will be B. Okay, let's do question 17. A small equilateral triangle sits inside a larger equilateral triangle as shown. What is the ratio of the areas of the smaller and larger equilateral triangles? Well, we know that this is 60 degrees. Okay, this is also, this is also, this is also, this is also, and this is also. So if we focus on this triangle, so if we have 2 lines and the angle between them, then we know the area of this triangle. So we also know this other line over here this one is also easy to find. So, but you just have to know the value of sine 30, cosine 30, cosine, like the popular numbers. If you know them, then easy peasy. So this line, you could look it up, like write cosine formula. for triangles. You could find this line if you want. So how do you find it? It's going to be this line is squared, okay, plus this sine is squared, okay, and then it's going to be minus 2 times of this side multiplied by this side and multiplied by cosine of the angle between them, cosine 60 degrees. So we could also find the area. It's very easy. Like you could also find the area of this. Okay, if you find the area, then the question is easy to do. The area is 6 times 2 times sine 60 degrees. Okay, because here is 60 degrees. So maybe you want to use this, or maybe you want to use this. I want to go with cosine, or let's go with the cosine. And the reason is it's more helpful for the next question to understand. So I'll go with that one. So cosine 60 degrees is 1 over 2. This 1 over 2 will cancel this. So we'll have 12 here, 2 times 6. So 36 plus 4, 40, minus 12, the square root of 28. So this is the square root of 28. Okay. So now we want the ratio of the areas, right? So this is the square root of 28. This line over here, this line, this side is 8. Okay. So we have two triangles that are similar. They're equilateral. All angles are the same. So the ratio of the areas is the same as the ratio of the lines, but squared. But where does square come from? It's because we're trying to find areas. These are lines, but the ratio of areas, that's why area gets a square. If we wanted to, like, if they were 3D shapes like this, right? They all had volume, like the next question that is coming up. Okay, then instead of this 2, you would have to put 3 because we're dealing with volume, not areas. Okay, so now I'll do the cleaning. Now this is the ratio of the areas. It's going to be 8 squared is 64. Square root of 28 squared is 28. So all we have to do is simplify. Divide them by 4. This is 16. This is 7. Will be B. And as I said, the next question has the similar idea. So let's just see here. Question. Okay, 18. The square pyramid shown is divided into 3 pieces, P, Q, R, by 2 planes that are parallel to the square base. Each of the 3 pieces has the same height. This is crucial. The volume of the piece P is 5. What is the volume of piece R, the last one, in centimeters cubed? Okay, so as I said, this one is, the volume of this is 5. And he said the volume, if the volume of this is, for example, H, the volume of the Q will be 2H. So you see that we have the ratios and the shapes are completely similar. And we have the ratios. This one height of height, this one 2H. So again, This one, this small one was 5. Now we want to find the volume of this bigger pyramid. Okay, we're interested in this one. Okay, so the ratio was 2/1 because the height was 2/1. Previous question, if you didn't watch it, we dealt with areas, so I put 2. Here are volumes, I put 3. So the red one is 8 times of this little piece. So this would be 8. This one was 5, the small one. So the red one is 40. Now let's go with the largest one. I'm going to go with this larger one. Okay. The large one, the same formula. The ratio of this with P, R over P, is 3/1. Because we're dealing with a volume, we're going to put 3. So it would be 27 times of this P. So R over P is 35. Oh, sorry, 27. Where's 35? 27. Okay. So the green one is 27 times 5. It's going to be 135. Okay. Yes. So now what does it want? We want the area of R. R will be 135 minus the red one, which is Q plus P. Okay, the red one. So 135 minus the red one, which is 40. It would be 95. It will be D. Okay, so let's go and deal with question 19. A sequence of values A1, A2 up to 800 is calculated as follows. We have 1, 2. So with all these questions, all of them are the same. You start to create them, you see the pattern, and then bang, the question solved. They take a little time though, right? These are usually time-consuming questions. So this is 1, this is 2. A3, this is 1. A2, it says it's 2. 2 plus 1. So A3 is actually 3. So where should I write it? A3 is actually 3. So it's growing. Okay. So if A4 is 4, A5 is 5, maybe that's the pattern, but I don't think so. So let's go with this one. Now A4 will be A3 over A2. A4, we want to find A4. A3 is 3. It's already 3. Okay. So A2 is 2. So 3 plus 1 over 2. A4 will be 2. So I was getting weird. So A4 is 2. Now let's go find A5. A4 will be here, which would be 2. A3 will be here. So it would be 2 plus 1 over 3. A5 is actually 1. Okay, now let's see A6. A6 will be A5 was 1. 1 plus 1. A4 will be 2. So this would be 6. A5 will be 1 plus 1. And again, A6. The A4 would be 2. It would be 1 again. So no, the pattern is not repeating. We had 1 and 2. Now we have 1 and 1. So we have to continue still. So A7, A6 will be 1. This would be 1. And now we see that this would be 2. So now we went back to the beginning. We have 1 and 2. So everything will be happening again over and over. So you see, this one, and this one are going back to the beginning. So is this one. This one is 2, and this one is 2. Okay. So that means this one, the red ones are similar. So if we add 5 to them, it becomes 1 again, and it goes back to the beginning. So we continue adding 5s, 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 5s. So this is the same. A6 is the same. A11 is the same. A16 is the same. Blah, blah, blah. A96 would be 1 again. We're here. So A97 is this one. A98 is this one. A99 is this one. So A100 is again 1. So the answer will be A1. So let me clear it. This is the right answer. So I think this question 20, I have done it. For intermediate level, this question is repeating again. We see probably here instead of question 20, there was like question 23, 24. So it's also okay if you are senior level, you could practice with intermediate material. Okay. So a trigonometry ramp is in the shape of this right angle tetrahedron. The horizontal base is an equilateral triangle. Okay, so this one is also 8. So apex is 1. 2 faces are vertical. In square meters, what is the area of the sloping face? So we want this area. This is 1. This is 8. So 90 degrees Pythagorean theorem will give us this line, square root of 65. Again, another Pythagorean theorem. Okay, this one is 4. This is hypotenuse. This one I'm going to call it h. So h is squared plus 4 is squared equals square root of 65 is squared is 65. 4. So from here you will know h is 7. So if h is 7, I'm going to clean. H is 7. So we have the height, we have the base. 7 times 8 divided by 2. 28 is the right answer. Okay, let's do question 21. In my opinion, this question is too difficult to be question 21, but we're going to deal with it anyway. Well, we have a cuboctahedron is a solid formed by joining the midpoints of the edges of a cube as shown. What is the volume of this shape if the side length is 2? Okay. So to start off, we know that this is this one and this one. This is a right triangle. And this side is the same as this side. Okay, so I think you already know this is going to be A. This is going to be A, right? a squared plus a squared is going to be 4. So if you do that, you're going to have, this will be square root of 2. This would be square root of 2. So then we have the side of the, okay, the cube. So it's going to be 2 square root of 2. Okay, and it's going to be cube. So the volume will be 16 square root of 2. That would be the volume of the cube. So to find the volume of cube octahedron, okay, we just need to find the volume of this pyramid. Okay, so to find the volume of this, okay, but remember we have 8 of this. So if we find one of this number, 16 square root of 2 minus 8 of the volume of the pyramid. So we need to find the volume of the pyramid, then the question will be done for. Okay, so now how to find the volume of a pyramid? Okay, let's assume that this equilateral triangle is the base, right? This is 2, right? So we need to find this area and we multiply it by the height. So to find the volume of this, we need to find the area. We multiply it by the height. And because it's a pyramid, we need to multiply it by 1 over 3. Okay, so we need to do this to find the volume of the pyramid. So let's find the area first. Okay, the area of a equilateral triangle, I hope you have memorized the formula, is going to be a square root of 3 over 4 a cubed. A would be the side. Okay, a would be this 2 over here. So it will be multiplied by 2 squared. Okay, this will cancel. So we have the area. This area is the square root of 3. So then all we need to find here is finding h. If we have h, this is the end of the question. But finding h is not as easy as you think, right? So to understand it better, I have to do my best to draw a better picture so that we could see things clearly. Okay, so it's going to be more like this. And this one is passing behind it. Not the best. So now what we have is this one. The base is 2, but these sides are a square root of 2. Okay, this is also a square root of 2. This is also a square root of 2. Okay. So now we want the height. Okay. The height will be at the centroid of this equilateral triangle. So let me just use a different color. So this would be, oops. So let me draw it like this. Okay, this would be the height. And this is at the centroid. So as you see, okay, this will make, again, another right triangle. So this is h. We want this h. We have a square root of 2, but we need to find this side again. So I will draw this one again, but we also have it. So maybe I could use this one. This is again the base that we have. Okay. This is the same base, purple. Okay, and this one, we need to find this. I'll also make it yellow. This would be the centroid over here. So we'll go, okay, if we draw 3 medians, my picture is not very good. Okay, this would be the centroid. The centroid would be 2/3 of the median. So in other words, we need to find this line. Okay, if we find this line, 2/3 of this, okay, will be this line that we need over here. So let's find this one. We multiply it by 2/3, then we get this line, and then the question will be over. So let's see. Remember, this was 2. This is half of 2. So this will be 1. Okay. This would be 2. This is a right triangle. So this one over here would be a square root of 3. Okay, this one over here. The square root of 3 plus 1 squared is 4. Square root of 4 is this 2. Okay, so as I said, this is 2/3. So we want to find this, which is this. This was 3. So the value of this would be, make it as yellow. So 2/3 of square root of 3. So we could cancel this. Let's just, this one and this one. It would be 2 over square root of 3. Okay, the question is over now. We have everything we need. Okay, so we're going to have h squared. Okay, plus this one was 2 over square root of 3 squared would be a square root of 2 squared. Okay, so we're going to have h squared equals 2 minus 4 over 3 4/3. So h would be, okay, a square root of 2 over 3. I could also write it as square root of 2 over square root of 3. There you go, we have this. Square root of 2 over square root of 3 multiplied by 1 over 3. So this will give us the volume of the pyramid. We have it. Let's just go and simplify. We no longer need any of these. So let's simplify a little. So as you see, this and this will cancel. So VP would be square root of 2 over 3. Okay, let's go and replace that. Okay, so instead of VP, I'm going to write square root of 2 over 3. Okay, so what we're going to have is, I'm going to write 16 is square root of 2 minus 8 square root of 2 over 3. Instead of 16, I'm going to write 48 over 3. So let's take out square root of 2 over 3. So it's going to be 48 minus 8 square root of 2 over 3. Bang, this will be 40. So the right answer is B. Was it worth this point 5 marks? No, no. But if you, there's also, you could look it up, there's also a formula for cuboctahedron. I think it was like this, but I don't think people can memorize this, all these formulas. What was it? You could look it up, I forgot. See? So this is how you can find it. This is the volume, okay? So question 21 I said was difficult, but this 22 is, in my opinion, much, much easier, and you can get the answer much, much faster. In the two equations, each of the letters A, B, C, D, E, and F is replaced by a different digit from 1 to 9. When the two equations are solved for x and y, the lowest possible value of x plus y is. Okay, let's go and solve it. So let's solve this one for x. This one. We'll add plus b to both sides. So we're going to have ax equals b plus c. Dividing both sides by a. So we're going to have x equals b plus c over a. Okay, so let's do the same thing for y. For y, if we do the same process, it's going to be y equals f minus e over d. So it says we want to find the lowest possible value for this. Okay, for x plus y. So x plus y would be adding these two things. Okay, so we're going to have x plus y will be b plus c over a plus f minus e over d. So now we want to get the lowest possible value. You see that this one, the left expression, this one, okay, everything is positive, right? So we want to make this one as low as possible. But we have this negative over here, negative e. We want to make this as e as high as possible because we have a large, okay, negative. So to make this as low as possible, I'm going to assign 9 to this. Okay. So again, you see we have now 1. We want to maximize this. I could put this one 1 here and then 2 here. That would create negative 8 over 2, negative 4. But how about putting this 2 over here and this 1 over here? That's pretty smart, isn't it? So it's going to give us negative 7. See, this one already, this term, if I assign it like this is negative 7. Okay. And we have already used up 1, 2, and 9. Okay. So here is also a different digit. So that means you cannot repeat the digits we have used. So we want to, okay, minimize this one. So to minimize this, I'm going to assign 8 to this, the second biggest number. Okay. And this one, the smallest possible numbers that are left are 3 and a 4. Okay. So which one is it? When the two equations are solved, the lowest possible value of x plus y is, you see, negative 7 plus this one. The only option that has this value in it is option B. Much easier than the previous question, isn't it? Okay, so let's go. Okay, question 23. A semicircle is inscribed in a right-angled isosceles triangle, and a square is inscribed in the semicircle as shown. What is the ratio of the area of the square to the area of the triangle? Again, it's a test and it's a ratio question. So I could call this A, but I'm not going to do it. It would just make the question harder. Why? Because if I call this one A, then I have to call this one A over 2. Why would I do this? So I will call this one, I assume this is 2. Okay. Now this one and this one. So if I draw it like this, so now this will give me the radius of the circle. Okay. So this is half of the square. So this one will be a square root of 5. 1 squared plus 2 squared. Let me write it. 1 squared plus 2 squared. Of course, it would be square root of 5. So we have the radius. Okay, I think a lot of you have already done this part and this much. Okay, so if we now have the radius, okay, so how is that helping? The radius is the square root of 5. Okay, that also means, okay, so from the center of the circle, if I draw this line, so let me make it smaller. So from here to here, this is the radius. This is again a square root of 5. Make it purple. Square, this is also a square root of 5. Okay. Now, see, all we have to do from here is complete this shape, like to make it a, now I'm moving myself, to make this into a full circle. And I will complete these sides. I'll make it black. Again, this would be the shape. Okay, it said this was an isosceles triangle. So this side is the same as this side, and this side equal to this side equal to this, 90 degrees. So this is a square. So we just have to find the area of a square and divide it by 2. It will give us the area of the triangle. So if this is a square root of 5, so let's find the side of the square here would be 2 square root of 5. Let me make this green. 2 square root of 5. Okay, so what would be the area of the square? Of course, 2 square root of 5 squared, which would be 4 times 5, 20. So the area of the square is 20. And now this triangle over here is half of 20. So this was 10. The area of this is 10. So now what does the question want? The ratio of the square to the triangle. Remember, we called this, I said, this is 2. If this is 2, then the area of the square will be 4. And then the area of this triangle would be 10. So 4 over 10 is the same as 2 over 4, 2 and 5. So that's the ratio. C is the right answer. In the grid shown, the numbers 1 to 8 are placed so that when joined in ascending order, they make a trail. Okay, so what does it mean ascending order? It's easy, like 1, 2, 3, 4, 5. Well, you can't go 1, 5, 6, 8, 2, right? One by one. The trail moves from one square to an adjacent square. Adjacent, if you're a non-native speaker, means a neighbor. Like you can't jump from 1. If 2 is here, you can't jump, right? But does not move diagonally Okay. You can only go up and right, down, up, left. You can't go like this. This is diagonal. In how many ways can numbers 1 to 8 be placed in the grid to give such a trail? So let me just draw the box. Okay. See. Okay. Here, and then I need 3 lines. Oh. Okay. Let me finish. Okay. There you go. We got this. Now, if you agree with me, see, if 1 is here, then would have to go, where could be the placement of 8? For example, can 8 be here? Of course, yes. We could go like this. So, but what is important here? If 1 is here, it doesn't matter. 1 is here, or 1 is here on each corner. The numbers we find is repeated, right? We just have to do one case, and without loss of generality, okay, we could apply it to 4 corners. The same thing. We just have to do it for 1 over here. Okay, and then whatever we find for here, we multiply it by 4 because it doesn't matter where 1 is. Okay, so let's do it. It will be clear. So if 1 is here, now I said 8 could be here, so that's 1. Could 8 be here? 1, 2, 2, 2. Yes, 8 could be here too. So this one was possible for 8. This one was possible for 8. How about this? Can 8 be here? If we go like this, I can't. If I go like this, I can't. Okay, it would be 7. So this is out. Now, can 8 be here? No. So if I go like this, I can't. So 8 cannot be here either. How about this one? Can 8 be here? If I go up, right, left, yes, it's possible. So 8 could also go here. So how about this? Could 8 be here? All I have to do, no, I can't. Is there another possible way? No. So this one, 8 cannot be here, but can it be here? I think the answer is a yes. Yes. So as you see, 1 here and 8 here, 1, 2, 3, 4. Okay. But are we going to do this again, the same thing? If 1 is here and then 1 is here, or 1 is here, are we going to do it again? No, it will produce the same result. So we have 4 corners. Each one produces 4. So we're going to have 4 times 4, 4 corners. Let me just clean everything. So we're going to have 4 times 4. Plus. Now what happens if 1 is in one of this? Again, we're just going to do it once. If 1 is here, is it possible for the 8 to be here? Yes. So, is it possible for 8 to be here? You could see that no, it's not possible. How about this? If we go like this, of course not. Is it possible for 8 to be here? If I go, well, I can't. So again, no. So is it possible for 8 to be here? While I go, yes. So how about this? If I go, is it possible for 8 to be here? Yes. How about this one? Is it possible for this one to be here? Well, I do have to go left, No. So as you see, for this one, only 3 right answers. Okay, but again, if 1 is here, the same thing will produce here. So we have 4 like this. Each one was 3. So this is the right answer. We're going to have 16 plus 12 is 28. This is the right answer. When I cycled around the lake yesterday, my children S and W decided to ride the same route in the opposite direction. We all set off at the same time from the same point, okay, and finished at the same spot. Okay, we each rode at our own steady, constant speed. It took me 77 minutes. Sally and I passed each other, waving exactly 42 minutes after we start. Precisely 2 minutes later, while W and I passed each other, puffing. To the nearest minute, how much longer did W take than Sally to ride around the lake? Okay. So again, remember it's a test. Okay. So we just have to make it as easy as possible, right? So, but just to see the question, first probably the mother or the father goes like this. First, they meet with Sally, and then so first Sally would go like this, and they meet here. The mom will continue, and then you will just see W. So W is slower. It's the slowest of all of them. Okay. So now we just have to say again, how large is this ring shape stuff? So some people would just call this S, for example, the total distance. Okay, or you could call it D. I would make it as easy as possible. I call this 77. What? 77 meters, right? Right. And the speed here, and it took the parent 77 minutes to go like this. So what is the speed of the mother, for example? Yeah. So it would be 77 meters in 77 minutes. So the speed of the mother would be 1 meter over a minute. That's slower than a snail, but that's okay. So this is the speed. The speed of the mother is 1. Okay. So let's go and see the other people's speed. So in 42 minutes, the mother has gone 42 meters. Okay, this is 42 meters. So for Sally, Sally has gone how many meters? Okay, 77 minus 42. Okay, it would be 35. So Sally has gone 35 meters. But in how many minutes? Remember, the speed of mother was 1 meter per second. So how long has it taken? The mother has gone 42, so 42 minutes. So the speed of the Sally is 35 meters. In how many minutes? 42 minutes. Because if the mother is 42 meters, that means the mother is 42 minutes. That's for S. Now we also have W. For W, I change. So the mother will go for 2 more meters. So it would become 44 meters. Two more minutes, 2 more meters. And then here, W will go all the way here. Okay, so it would be 33 meters. Okay, so W will go 33. Okay, so let's see. W will be 33 meters. Okay. Also, I have to move myself a little. So in how many minutes? In 44 minutes. Okay. So we have their speed. The speed of Sally, the speed of W. Okay. And remember the whole rank, we assumed it was 77 meters. So let's go and answer the question now. Let's see if I can do this. Okay, so let me do some cleaning. Okay. So how many minutes will it take for Sally to go 77 meters? Okay, to go all of this. He would go 35 in 42 minutes. So it will take 77 divided by 35 multiplied by 42. By the way, we could have simplified these. I'll simplify them now. So how many minutes will it take for him to do that? It's going to be this divided by 7 is 5. This one is 6. Okay. So it would be, I'm going to write it like this. 77 over 6 over 5. That would be for Sally. This is how many minutes will take for Sally. This is minutes. Let's do the same thing for W. For W to go, it was 77 meters. Okay, it would go 33 meters in 44. Okay, this one simplified by 11 will be 3. This one will be 4. Okay, so this would be for 77 multiplied by 4 over 3. That would be how many minutes will take for W. You see the reason I didn't multiply it? Because I didn't have to. Okay, now W was slower. So we'll take more time for him. So let's just write it here. I'm going to do some cleaning again. Oh my God. Can I get it back? Okay. So it would be 77 multiplied by 6 over 5. The other one was 77 multiplied by 4 over 3. Okay, this was S, this was W. So we want W minus S. Okay, so I'll factorize. So 77, 4 over 3 minus 6 over 5. Okay, we do this one. This would be the right answer. Okay, let's go. So here it would be 77 times. This would be 15. This would be 20. Okay. Minus 18. To the nearest minute, we have to round it. I was just wondering why isn't the perfect number. So it will be 77 over 15 multiplied by 2. To round it, I'll make this one, turn it into 75. This would be 1. This would be 5. So almost 10 minutes. The right answer is approximately more than 10 minutes. When you round it, it becomes 10 minutes. So question 25 is E. Question 26. Horton has a regular hexagon of area 60. For each choice of 3 vertices of the hexagon, he writes down the area of the triangle with these 3 vertices. What is the sum of the 20 areas that Horton writes down? Okay, so Let's see. So it's telling you that there are 20 areas and 20 triangles. Okay, so how many different kind of triangles can we make? This is one, right? Okay, this is one kind I can make. And then how many of these do we have? We just have to find it. This is one. If I go like this would be another one. Remember that I'm choosing the 3 points or vertices that are neighbors, like this, this, this. Okay. Then I could go with this, this, this. Then this one, and this one. Each of these will create this triangle. So we have 6 points. So starting with this one to be the first, we can go like around. So we'll have 6 of these. We have 6 points, so 6 triangles like this. I'm gonna write it, call it, just draw like this. Okay, we have 6 of this. So now imagine from this point, I want to not have any of the neighborings. So this would be, okay, but I would choose 2 that are neighbors. For each point, I could have this one. If I choose this one, I could also connect it like this. So for each one, like this, I'll have 2. So this is 1 point. We have 6 points. So we're going to have 12 of them that look like this. That's 18. So we have more. 2 more. Which one are those 2? This one. This is 1. The other missing one. And we also have this one. Okay, so that's the 20 triangles we have. We just need to find their areas. So let's just go. We have 2 of these bigger ones. So the reason the question has chosen 60 is because they want to make the question easier. 60 is divisible by 6. So for example, if I have this one, so how many of them can I make like this? This is going to be 2. This would be 3 of them. But if this is the center, you would see that I could turn it into 6 of these. So the area of this 60 divided by 6, the area of this was 10. So this is 10. Let's see the story for the other ones. It was like this. Okay. That was 1. Okay. So this would be the other one. Okay. But it wouldn't be helpful. So we want this area, number 2. So to find this area, let me make it turn into a line to be neat. So from the center, if I go like this, okay, you see this area, the black one, will turn into two things. This one, this black one, is something we already know. Previously, we said that was 10, right? This one, we said previously 10. It's this shape, 10. This is also another 10 too. Why? Because if I make it like this, 10, 10, 10, 10, 10, 10. So this shape over here is made of 2 10s. So this is 20. So the last shape of all of them, this one, it was this one, and this one. Okay. So as you see, we had this one. This one is half of the area because if I do it like this, the shape will turn into 6 of these, and this shape is 3 of those. So this is 30. let's go. This is going to be 6 times 10, 60. 12, 20, 240, 60. We'll make a total of 360, which is the right answer for question 26. An even square number is multiplied by an odd cube greater than 1, resulting in a fourth power. If the fourth power is as small as possible, what is the sum of the square and the cube? So let's see. What is the smaller fourth power you could call? We could name. It's probably 1. Okay, and then it would be 16, which is 2 to the fourth power. This is 1 to the fourth power. And then 3 to the fourth power will be 81. Okay. So, but sometimes the number could be written like this. Sometimes 6 to the fourth power. Of course, it's the same as these two combined. 2 to the fourth power multiplied by 3 to the fourth power. So this is again a fourth power. How about something else? What if I write this as, okay, 2 to the 8th power multiplied by 3 to the 8th power? Okay, it would be 6 to the 8th power. Is this also a fourth power? The answer is yes. So as long as these numbers are divisible by 4, you are able to write them as a fourth power. So, for example, what is this number? Okay, this one, 2 to power of 8, I could write it as 4 to power of 4 multiplied by 9 to power of 4. So it will be 36 to the fourth power, in case you wonder. Okay, so I gave you this small introduction. So let's go and deal with this question. Okay, so, and we want to make it as small as possible. So let's write the smallest possible number. It would be 2 to the fourth power multiplied by 3, which is the odd, but it has to be cubed. Even square number is multiplied is an even square number, so I wrote it wrong. The smallest one would be like this. So as you see, none of the numbers, not 2, not 3, they're not divisible by 4. So what I could do, I'll make it slightly larger. The next even number is 4. This one is good enough. 4 to the second power, 4 squared is 16. I could write it as this. This is also 16. So we have dealt with this. Okay, this one is okay. It's divisible by 4. This one isn't. So what can we do? So the next number I could write, okay, what if I write instead of this, I write 2 to the fourth power, and I would choose 9 to the third power. Okay, so what happens? Okay, instead of 9 to the third power, I could write it as 3 to power of 2, which is 9, again to power of 3. Okay, so this number, I'm going to write it here, a better line. Okay, so this number, let's write it here. It would be 2 to the fourth power multiplied by 3 to the sixth power. Okay, again, this is not helping. Okay, but remember, this number was 4 to the second power. This is 6. if I add a +2 to here, if we have a +2, then it would be divisible by 8. So to add a +2, remember this was 4 to the second power. What if I add a 3 here? It's still this number instead of this number. It will become 12 to the second power. So let's write it here. Instead of this, let's try these two numbers. 12 to the second power, even the square number, multiplied by 9 cubed. Okay. So as you see now, this number, let's see if this is the right answer, if we could write it as fourth power. So 12 to the second power is the same as 4 to the power of 2 multiplied by 3 squared. This one, we showed it here. This is the same as 3 to the 6th power. Okay, there you go. We got it. So this is 3 to the 8th power. 4 squared is the same as, we showed it here, 2 to the 4th power. 4 is divisible by 4. 8 is also divisible by 4. So this is the right answer. Okay, so there you go. We got our answer. It's going to be 12 squared times 9 cubed. We just need the sum of them. We need to add them. So 9 cubed, 9 squared is 81, multiplied by another 9, 729. 12 squared is plus 144. So it's going to be 800, okay, 3 and 7. So there you go. So this is the answer to question 27. Okay, question 28. And do you remember I said question 21 was too difficult to be here? I think question 28 is too easy to be here. Well, in an infinite sequence, the first two terms are 2 and 6. And apart from the first term, 2, each term is 1 less than the average of its two neighbors. What is the largest term which is less than 1,000? Okay, let's just write some of them. We know that the first one is 2, the next one is 6, and the third one is, this is 1 less than the average of 2 and the other number. So the average of these two numbers is 7. So the average of two numbers is 7. So the sum of them have to be 14. 14 minus 2 is 12. Now you could just find the average. 12 plus 2 is 14, divided by 2 is 7. So the same thing. The average of these two numbers is supposed to be 13. 13 times 2, 26. Minus 6, 20. Okay, let's see. 20 plus 1, 21. Times 2, 42. Minus 12, 30. Okay, so the next one, 31 times 2, 62. Minus 20, 42. So you could see now, you could see the jumps. This one has been, let me change color. This one has been plus by 6, then plus by 8, then plus by 10, then plus by 12. And you could continue this. How many of them will be? Like 20, maybe something like this, around this. Then what is the last number that is less than 1,000? You could sum them up. It would take 2 or 3 minutes, but you have to be careful not to make a mistake. If you don't want to add all of them, so we could write this one as, you see, I'm going to rewrite everything as, the first one was 2. From here, it was 6. Then from here, 12 was 6 plus 6. And the third term was plus 8. Now 6 plus 6 plus 8 is 20. And then plus 10, 20 plus 10, 30. And then 12. So you just want to continue adding these until you get to a number less than 1,000. So from here, you just have to make a guess. My guess would be 30. So from here to here, I would love to go with 30 terms. If we have 30 terms, what is the last number? The last number would be 6, and we're going to have 29 times, okay? Each one multiplied by 2. So the last number will be 6 plus 29 times 2, 58, 64. So the last number is actually 64. This is my guess. So let's just, what is the sum of this? We know how to sum this. We have 30 terms. These two together, the last and the first, we're going to have, and then the second, and then the second from here. We'll have 15 pairs, and each pair will be 64 plus 6. 64 plus 6 times, we'll have 15 of these pairs. So it will be 70 times 15, 1,550. Remember, we didn't count this 6. So 1,056 would be all of this. Okay. So this is, my guess was a little extra. So let's remove this number. We have 1,056 minus 64. It would be 2, and then this one. Okay. 99. Okay. So the right answer is 992. Question 29. Wasteful Wayne takes one sheet of paper with my document printed on it. He runs it through the photocopier to make 2 copies, which he then stamps with his copy stamp. Okay, so I'm going to show it like this. This is the original one. Okay. Then he makes 2 copies. And he writes on them, bank copy once. So this is after one time of doing it. Wayne then takes the original and the 2 copies, runs them all 3 through the photocopier to make 2 copies of each, stamps the 6 new copies with his copy stamp, and then adds them to the top of the pile. Okay, let's see. Now, these 2, this original one, it has no copy stamp on it. So when he makes 2 copies, nothing is written on them. So he stamped them. This one becomes 1, this becomes 1. But these 2, each of these already has a copy sign on it. So he stamped it one more time. Okay, he makes 2 copies, stamp it one more time. So they have 2 on them. This one also 2. This one also 2. So if you continue like this, right? So these 4 purples, okay, each of them will create 2 greens. So next step, 8 greens will be added. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all of them have 2. And this red one will create 2 more purple. So we'll have like this. And these 4, they will make 8 threes, right? The ones that have 3 stamps on them. Now, what does the question want? He repeats this process by making 2 copies of each sheet of paper in his existing pile, stamping the new copies, then adding them to the pile. So the pile triples in size each time. After Wayne has done this 8 times in total, the pile is 6,561 sheets high. How many sheets have exactly 2 copy stamps on them? Okay. One thing, you see, when these 4 that we have, okay, they will never be ruined, right? So we have this 4. And then 8 more will be added here. So after doing this for 3 times, we have a 4 and an 8, so it will be 12. Next step, these 6 will create 12 more. So it becomes 24. So, and then what happens? I'm going to make a chart to make it easier. That was the 4th time. So let's make a little chart here. So we have the ones with 0 copies on them, the one that have 1 copy on them, the one that have 2, and we don't care about the rest. Okay, at first, the first time we do it, we just have this one, the red one, and then we make 2. So it's going to be 1, 2 only. The next time that we did it, we ended up having 4. We had 2 of this. Next time we did it, we ended up having 4 ones, and we ended up having 4 greens. So, and then here, the next time, this becomes plus by 2, okay? And this one was plus by 8, it became 12. Next step, each time, the original one creates 2 ones. So this becomes 8. This one, this 6, will produce, we'd add 6 times 2. So it would be 12 plus 6 times 2, 24, which we have it here. We have done this 4 times. Then it becomes 10. This becomes 12. 1 time, 2, 3, 4, 5, 6, 7 times. We do this 7 times, and the last times this will be 18. But we're looking for the ones that have 2 copies on them. So this one will be plus by 2. Next time it will be plus by 8 times 2. 24 plus 8 times 2 is 40. So you see the pattern now, right? This one was plus by 8. Then this one was plus by 12. Then plus by 16. Each time it's being plus by 4 more. So next time it will be plus by 20. So we're going to get a 60 here. Okay. And then plus by 24, 84. And then plus by 26. Okay. It would be, am I right? So 26, 110. Let's see. I got myself confused. So this is 16. Okay, 40. And then plus by 20. And then plus by 24. And then plus by 26. So let's just add them. Plus by 20, 60. Plus by 24, 84. So here will be 110. Okay, so I made a little mistake here. This is not 26. We're supposed to add them by 4. So this would be plus 28. So this one will be 2 more. So the right answer to the question will be 112. This is the right answer. Ali, Beth, Chen, Dom, and Ella finish a race in alphabetical order. Ali in the first place, then B, C, D, and E, like the way I wrote it here. The next week they run another race and their placings all change. 2 of the runners receive a placing higher than last week. than the week before, and the other 3 runners receive a placing lower than the week before. Given this information, in how many ways, in how many orders could the 5 runners have finished the second race? Okay, just one thing, we know that one of the people that definitely has to go up is E, okay? And only one of the other ones have to go up. Maybe D goes up, C goes up, or B goes up. Okay, given that, okay, I tried to write them. I couldn't spot a pattern. And if you find a pattern, it's not worth it. You can just write all the orders. It wouldn't be too many. And I couldn't think of something smarter. So I'll just write some of them here. So for example, the first one is, what if A goes down 1 and E goes back up? If you think like this, A goes down. So one case would be like this, D, E, and C. So the other one will be E, C, B, A, and D. Okay. So now the next arrangement. What if A goes down, but E goes 2 up, right? You could just come up right like this. So C, D, D, B, C, B, and then D, B, C. Okay, the other one that I wrote here is just like E goes all the way up, A goes still 1 down. So D, D has to go up, BC will go down, and then CB. Okay, so this is 7. If you continue writing like this, or with organization, you'll find that there are 14 more. Okay, so the total number would be 21, but I'm not going to write all of them. If you can spot a pattern, or like being smart about this, please write it in the comment section. Thank you.